Resistors are probably the most common component used in electronics. They're cheap, easy to use, and most of all, versatile. You will find them in nearly every electronic circuit out there. Even if you're not tinkering with electronics, every device you use has a ton of resistors inside it. So what exactly does a resistor do, and why are they so important? Well, think about electricity like water flowing through a pipe. If the pipe has nothing in it, then the water can flow freely. But if we put something in the pipe like a partially closed valve, then we're restricting how much water can get through. This restriction is similar to how a resistor restricts the flow of electrons or electrical current, by controlling how much current flows through a circuit. Resistors help manage the voltage drop across different parts of the circuit. This is important because many components like LEDs have a specific voltage they need to operate properly. Without a resistor to limit the current, these components would draw too much current and burn out. There are many different types of resistors, such as fixed, variable, carbon film, metal film, and wire wound, just to name a few. Each type has its own use depending on accuracy, cost, and power handling requirements. Resistors also come in different sizes, ranging from tiny surface mount resistors, used in portable devices, to large power resistors used in audio amplifiers. The value of a resistor is measured in OHM'S and is usually written in this weird scientific notation. For example, this resistor has a value of 100 OHM'S, while this one has a value of 2.2 kilo OHM'S, or 2,200 OHM'S. The standard value for this resistor is 10 OHM'S. But how do we know these values? How do we read the markings on a resistor? Well, resistors have colored bands printed on their bodies that indicate their value. Each color represents a number according to a standard code. For example, this resistor has a brown, black, red, and gold color scheme. Using the resistor color code, we can see that brown equals 1, black equals 0, red equals 2, so the first two colors represent the first two digits of the resistance value. And the third color, 2, represents the multiplier, which in this case is 10 to the second power. So 10 times 10 equals 100. Finally, the fourth color, gold, represents the tolerance rating of the resistor. Tolerance indicates how close the actual resistance of the resistor is to its labeled value. A plus-minus 5% tolerance means that this resistor could have an actual resistance anywhere between 95 ohms and 105 ohms. In addition to the value, resistors also have a power rating that tells you how much heat they can safely handle. Too much power can cause the resistor to overheat and burn out. So it's important to choose a resistor with a high enough power rating for your application. You can use the following chart to get an idea of what power rating you will need for your resistor based on the wattage or power being dissipated by the resistor. The higher the power rating, the larger the resistor needs to be. So now that you know the basics of how resistors work and how to read their values, how do you actually pick one out for your project? Well, it all depends on what you're trying to do. Do you want to build a simple LED project? Or are you designing a complex electronic system? Maybe you're somewhere in between. Either way, the first step is to figure out what value resistor you need. We can use a handy little formula called Ohm's law to figure this out. Ohm's law states that voltage equals current times resistance. Or more commonly rearranged, resistance equals voltage divided by current. Using this formula, we can solve for resistance by plugging in the voltage and current values for our circuit. Let us say we're rebuilding a simple LED circuit with a 9-volt battery and an LED. It needs a current of 20 milliamps or 0.02 amps to operate properly. We can use Ohm's law to solve for the resistance needed. So, resistance equals 9 volts divided by 0.02 amps, which equals 450 ohms. So we know we need a resistor with a value of around 450 ohms. But we also need to take into account the power rating of the resistor. If we're using a 9-volt battery, then we'll need a resistor with a power rating of at least 0.25 watts. Whether you're building a simple LED project or designing a complex electronic system, understanding how resistors work and how to use them correctly is a foundational skill in electronics. Hopefully this video helped you understand a little bit more about this essential component and how it is used in circuits. Thanks for watching, and I hope you learned something new. If you did, consider subscribing and check out some of our other videos.